so let's start right in the bat. Okay, so topic today, we're talking about things called sequences, okay? And all sequences happen to be what we call an ordered set of numbers, okay? Okay, it's an ordered set of numbers. That's all a sequence is, okay? So this particular chapter is called Rock Band because the whole scenario is a rock band that goes out, they make music, they sell CDs, and at the same time then they put albums out. So they're trying to make money. They go on tour. No, I didn't make this.
So can we name the rock band?
If you need to, Landon. Okay. They have a name though. I think they're called Stellar's Attractions. Okay, they are called. Okay. Now, so in this activity, okay, Landon, why don't you read it to me, okay? In this, good.
I can't read. And where?
In this activity, go ahead and read it for me.
In this activity, you investigate the basic number patterns formed by the number of performances during Stellar First World Tour.
Okay, good. Okay, so keep reading.
Why not?
Wait, is it first world tour or is it like in a first world country?
Okay, so it reads.
I go, okay. Explorate, wait.
The first word.
Explorate.
Before starting their world tour, the band's concert career was relatively short, only 6 performances. The upcoming schedule, however, contains 2 performances per week. Table 1 summarizes the band's career performances over the next 10-week period.
Okay, table 1 summarizes the band's career. So let's do over the next 10. So I want you to extend this chart. So I want you to go ahead and make the chart go all the way to 10. So you got 4, let's go 5, 6, 7, 8, 9, 10. Okay, so see if you can find the pattern. Hopefully it's real easy, right?
Do it.
Okay, it goes up 2 times each time.
Okay. So obviously they go up by 2. I heard Lana say that, up by 2 each time. So they get 2 more performances each. Okay, so then what about number 50? What about week 50, okay? So if we do week 50, we could just extend this all the way to 50, but the problem is that we go from 10 all the way to 50, which we could do. Or we could come up with an idea. What do you got, Ben?
How about we graph it?
Make
So
an equation.
y equals 2x plus 6.
Plus 6. Interesting. Where did the 6 come
That
from?
was their original 6.
That was their original 6 performances, right? And like Lana said, let's make an equation, or we can make a formula. Okay, so then our formula would be, we can plug in our 50, right? Yes.
Would it be 2x? Would it be
106.
That's like doubling it.
So,
Yeah.
well, let's see if our formula works. If I plug in 2,
That's true. There you go.
okay, okay, Isaac, turn around, don't talk to him. Okay, so if we try 50, y equals 2 times 50 plus 6 should be 106. Okay, performances total, okay?
I have a question.
Okay, yes.
Why do we need to make a formula? Because it says, can we make a formula?
Right, and we can, right? We can, and
Why would we need to?
great question. How would you answer this question?
106.
Okay, so you doubled it and added 6, right? So you kind of made an algorithm or formula in your head, right? Okay, let's turn the page. All right, not too bad. So, sequences. Let's define a sequence. It is an ordered set of numbers. So what we had was 6, 8, 10, 12, 14 dot 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 dot. That's a sequence. We know there's a pattern, so a group of numbers, a set of numbers, and there's definitely some kind of pattern. Patterns by adding to, adding to, adding to. Now, if it's an arithmetic sequence, it's exactly what we did. We are going to be adding or subtracting to make the next term. So an arithmetic sequence is where we add or subtract to make the next term. So in this case, we just went add to, add to, add to. This one is arithmetic. So when you think about the word arithmetic, think add, okay? Now you could also subtract, and that's also arithmetic, but it's like adding a negative, adding a negative, adding a negative. So basically like subtract, okay? Now, Price actually had a little bit of a aha moment, because you say, wait a minute, how can that be 2? You're not multiplying by 2 each. You said that, right? You said you're not multiplying by 2 each time, you're just adding 2. In fact, we want to go ahead and see how that works, because you actually saw something pretty good. So a thing called a recursive formula. To do a recursive formula, then, it's actually going to say what we're going to do. Because Price, when we did this, it didn't show add 2, did it? It didn't make a whole lot of sense until you thought about you going up by 2, like slope, right? So a recursive formula, though, is a formula that actually shows what's going on. So, for example, A1 is the first term, and then A of n is going to be equal to A to the n minus 1 plus D. Now, this is the recursive formula. Now, this isn't going to make a whole lot of sense to you right now at all. I'm going to highlight it, though, okay?
Wait, what is n?
N is the number of terms. So I'm going to have to do some really good teaching in the next couple of minutes, but you've got to really pay attention, okay? So, you paying attention, okay?
Yes.
So let's check it out. N is always these numbers. N is always the numbers 1, 2, 3, 4, dot, 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 okay?
Well, how do we know what yellow dots are?
Great. It depends on how many we want to make, right? So on the board, we're going to work on this one, okay? On the board, I want you to watch. I don't want you to write anything, I just want to watch. So my first example is A1. A1 is equal to 27. Okay, that means that's my first term. So in a sense, in my series, I've got 27 comma something. So the 1 represents the first term. A is the symbol for term, okay? So my first term is 27. So then my second term can be made by A of n equals A to the n minus 1 plus 5. Okay, please watch. Please, all eyes, okay? So I've got the first term. I need the second term. Agree? So if n is 1, 2, 3, 4, 5, so forth and so on, I've already made the first term. Let's make the second term. So let's make A2. Right? That means, in this case, the n we want to use right now is 2. Alright? So I want to make, I'll go back to the formula. Okay, the formula says n and n, right? So I've already made the first term, so I've already let n be 1. So let's make the next term. No, don't interrupt me, not right now, okay? Let's make the second term, okay? We've made the first term. So in the first term, n was 1, okay? Now n is going to be 2 to make the second term. So let's make the second term. So I'm going to replace the n with the 2. Replace the n with the 2. Let's see what we have. So A of 2, which is what we're really looking for, because that's going to be that guy right there, is equal to A1 plus 5. Now, I know what A1 is. A1 is 27, right? So this is really 27 plus 5. So I know that A2 is 33, right? 32. Okay? So now, 32. So now I know that A2 is equal to 32, right? A2 is 32. So let's make A3. So I've got my formula. A of n is equal to A to n minus 1 plus 5, right? So then to make the third term, watch carefully, make the third term, I need A3, right? So I'll make this 3. okay? You with me? So I'm making the third term, a of 3 equals, let's see, that's a of 2 plus 5, right? But I know what a of 2 is. It's 32, right? So I'll put 32 right here. And I get a 37. So A3 is 37, right? Now, at a certain point, you might say, wait a minute,
They're just going up 5.
they're just going up by 5s,
Well,
aren't they?
Then that's
Not really.
obvious, because there's
Yes.
a 5 in the middle.
Now,
So
and
you
I,
can only do one?
now, Landon, I start with an obvious one because they get more complicated, but I want you to see how
Well,
it works.
it's complicated.
So, let's see what this means. Let me back up, okay? Let me back up to the formula, okay? So let's look at let's look at this formula, okay? So if A of n is the term you, listen very carefully. If A of n is the term you want to make, we'll take its previous term. Its previous term. Now why am I saying previous? Because if this is the third, then this would have been the one before. If this is the fourth, then this would have been the one before it. So you just take the term you just made. So what we do is, just like you said, all we do is we're just going to add 5. So A1 is 27. So we take 27 plus 5 gives me 32. Take 32 plus 5 gives me 33. Take 33 plus 5, we get what?
34.
42, right? Take 42 and add 5 to it, you get,
46.
and then it keeps going and going and going. So now,
It's literally 2 and 7.
so in this case, here's what we need to know. This symbol right here means the previous term, okay? This is the, when you see a to the n minus 1, think previous term, okay? But you have to start somewhere because we say we use the previous term. That's why you need to put down A1. Because, okay, add 5 to the previous term. You need to know where you start. Does that make sense? You got to know where you start. Because say, just add 5, add 5, add 5, add 5. Okay, ready? Add 5, add 5, add 5, add 5. And Price is going to say add 5 to what? Right? The
previous
rule
number.
is add 5. Always add 5.
To the previous.
But you're going to say add 5 to what? Got to have a previous term. So you have to have always have to have the first term. And then you can just add 5 and add 5. Now it says graph this, right? So to graph this, I'm going to do a little bit of a squishy here, right? And I'm going to go, and we'll start with 25. We'll go 30, 35, 40, 45, 50, 55, 60, 65, 70, okay? And then I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I want you to label that, okay? These are my terms. And these are my answers. Okay? These are my terms and these are my answers. Now, our first term had a value of 27. So, 27. Our first term had a value of 27.
I have a question. If you want to make it really easy for you, just have the squishy go to 27 and each unit be 5.
Okay, real quick before I finish, you have it wrong. So hold that thought. Okay, hold that thought, okay? Second term. What's second term? Second term is 32. Third term is 37. 42. 37. Okay. 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 How am I doing? Now, why is Ben? Sorry, forgive me,
Why
Ben.
is Ben?
Why?
wrong?
Because Ben's normally right. Why is Ben's graph wrong?
Because he started at 0.
Is there a 0 term?
No.
So if I just erase the last box, I'm fine. Like the last tiny bit of that line.
No, you have to erase the entire line because you're now one below your should be.
He's still wrong. Even if you just go like this.
Oh, I see what I did wrong.
What did
We
you
gotta
do?
move it 1 unit to the left.
Brother, man.
No. What's the difference between these two? It should be obvious.
Actually, no, I understand.
That's what I said. I
That's what I
said
said.
1 unit to the left. If we move it 1 unit to the left, it's the same as adding 1.
So you want to go here?
Yes.
Go here.
Yes. Wait, no. Yeah. Put the start of the line there. No, I did.
You want to draw it?
Yeah.
Go ahead. You draw it. You draw it. You draw it. Okay. You draw it, Ben. I want
So-
to see this.
We're gonna start it here.
Okay. Draw it in.
Yeah, and then
You're still wrong.
oh.
Oh,
Okay.
snap.
What's the difference between the two graphs?
It doesn't go up by 5.
Nope. What's the difference between the two graphs? Come on, it's so obvious. Austin.
His end one up.
Slope.
You have to where it skips numbers.
It skips numbers.
What?
Yeah.
The little
Wait a
triangle.
minute. Hold on, Ben. You see, there are. Here, it's gonna be so obvious. There is a first term. There's a second term. There's a term. Is there a half term?
No.
Is there a 1.5 term? Is there a 2.2 term?
Yes.
You either have a value for your first term has a value. Boom. Your second term has a value. There's nothing in
Oh,
between.
so there's no line.
There's no line. There's nothing in between.
Also, yours ended on the wrong point.
So no. That wasn't what I saw. More than anything,
No, it did.
here's a first term value. There's a second term. Is there any? There's no 1.5 term. There shouldn't be anything in here, right? You have a value here, 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 and here. Now, real quickly, if you did draw a line, then one of the things you realize is that it is straight, right? You guys agree it's straight? Which means it's linear, right?
Yeah.
Okay, it's linear. Is this a function? Is mine a function? Yes, it's a function, right? Okay. Now, example 2. I want you to find the first 6 terms. Okay? Okay?
7, 4.
Write them
I
down.
did them.
Figured it out.
Yep, and then graph them. Okay? Get the first 6 terms. Then graph them, okay? So you know the first term is 10.
No way.
That's A1, right? A1 is 10. A2 is, there you go. A3 is, A4 is, A5 is,
-2.
A6 is,
-5.
there you go. And there is no A1.5, is there? There's nothing in between, okay? So let's go ahead and just graph those.
I have a line.
I'm done.
Okay, graph those.
Wait, no, I'm not. Wait, no, I'm not done.
Okay. So when you graph it, you should get so what I'm going to do when I make my graph, I'm going to do this first of all. My line straight across, go all the way to -5. Okay, I'm going like that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But do not put 10. Shh, 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 shh. Do not put 10 here. Because there's no 0 term, is there?
There's only one term.
There's a first term. There's a first term, not a 0 term. Yes. And then you'd have a 7, then a 4, then a 1, then a -2, and then a -5. Okay, there it is. Don't connect the dots, and don't have anything here. So we have 1, 2, 3, 4, 5, 6. Is it arithmetic?
Yes.
Yes. It's arithmetic because you're subtracting 3 each time. Yes, it's arithmetic. Okay? All right, so, real quickly. 2 big things. Okay? One, we label our terms by using these symbols. A1, sometimes they use T1, sometimes they even use N1, but our terms are listed by A1, A2, A3. Okay, there's no in-between terms, so when you graph it, it's a dot, 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 not a straight line, right? Arithmetic means you will look at a straight line, but it's adding the same thing each time, okay? So all we have, and I have homework for you, or